questions do we have? Want to see, go over on if we can? So. Mm-hmm. So you should have had your notes out from last class comparing it to this. So we're looking at the domain of this, just the domain. It says use set or interval. I'll write both for number 1. So this has arrows that keeps going left and right. Remember, your walls helps you find your domain. If this has an arrow that keeps going to the left and has an arrow that keeps going to the right, it's going to keep going forever and ever in both directions. So interval notation would be negative infinity to infinity. Set notation would be x in on. So you could have had either of those answers. It didn't ask you to find range or increasing, decreasing, constant, any of those, but you could have for practice. Questions on that? 2 is almost the same thing, because it also has arrows. So it keeps going to the left, definitely. It does keep going to the right, but there's this place right here that has an open circle. So at that place, it is not included. So how we would write that is, in interval notation, it would start at negative infinity. It would go to, this is counting right, 2, I'm assuming, 2, 4, 6. Why is it not so far? Because it's an open circle. If it was a closed circle, we wouldn't even be doing that. So we're just continue on. And we didn't talk about this, but there's a U in between it. That just means it stops at 6 and it continues at 6 again, but not including 6 to infinity. So that one was a weird one. So it's basically all real numbers except for at 6. Okay, questions on that one? If you do not have your calculator, you need to go grab that. You will need it. Alright, so today we're going to be talking about parent functions, what that means, and then transformations, how they're described, what they look like, all those type of things. Did that work?
Yeah.
So the very first thing we're going to do is graph this function. It should look familiar to you because we just graphed that a bunch of times. But go ahead and first clear out, reset your calculator. 2nd plus 712. And go into y equals and type in your graph. Or type in your function, x squared. And we're just going to go to the table to get the points. So go second graph. How we find the points is the same. We're looking for where y values repeat and in the middle. So 0, 0 would be our middle or vertex. And then it would go out from there. 1, 1, negative 1, 1. Negative 2, 4, positive 2, 4. And there's not enough space to do anything. So connect your U-shaped parabola. So this is one of your parent functions. You'll learn a lot more in Algebra 2. This is if nothing else happens to it, there aren't anything else attached to it, it's just x squared, it will always look like this. So your parent function is if nothing else changes, that's what it looks like. So then we're going to take our parent function and apply different changes to it and see what happens. So in your calculator, add 2 to the end of it in y equals, and then you can graph it. what is different from this compared to our parent function? Chris? It went up 2. So we're gonna, that would be our change. Went up 2. So it's good to note like what it actually did, being able to write that out, but then we need to know the actual rules. So we'll list out all these rules and we'll talk about what they actually look like and what they do and things like that. This would be a vertical shift up 2. So when we say our rules, we have to say what direction it went, vertical, horizontal, up, down. I'm sorry, what type of transformation happened, vertical or horizontal. Also what type shift, and you'll see others, and what direction, up, down, left, right, whatever, and then by how much. So we have to be very specific with that. So what do we think might happen when we do minus 1? Most likely. Put it in your calculator, graph it, just to make sure. So it did go down 2. So then it would be opposite, vertical shift down 2. Now these next 2 will look familiar for when we were talking about vertex, but let's put this next one in and see what happens. Make sure you're using your parentheses. And graph it. Compared to our parent function, what happened? It shifted to the left. So I'm going to say move to the left. That would be a horizontal shift. So as we were talking about our vertex before, how what's inside does the opposite, you would think it would move to the right 2 because it's plus, but it actually is opposite. It moved to the left 2. So same thing. Aiden. The graph on the, yep. Afterwards, you'll have to know these. You should know what these are, and we'll talk about how you'll start to memorize those. Right? So what do we think this one's going to do? The right. And I'll graph it just so we can confirm. But it did do that. Move to the right. So that would be a horizontal shift right 2. Then go ahead and put this next one in your calculator, 2x squared. And we're going to compare that to the original. What changed? Looks that way. Let's look at our distance. Yeah. So it looks narrower, sure. If we're looking at our table, instead of, it's still at 0, 0, so that didn't change, but instead of negative 1, 1, it's now at 2. Instead of negative 2, 4, it's now at 8. So it's like all your y values got multiplied by 2. We say it got narrower. That is called a stretch. Think about it like it's stretching towards your y-axis, so it's getting skinnier. We would say that's a vertical stretch by 2 or by a factor of 2, either or. So then with the next one, we change the 2 to a 1/2. So I just changed that to alpha y equals, and I'm going to get rid of the 2 by hitting delete. Graph that, see what happens. We're comparing that to the original. What does it look like happen? It got wider. So it's shrinking away from the y-axis. So that would be a vertical compression. Vertical compression by 1/2 or vertical compression by a factor of 1/2. So this next one is the last real type, and then they start to combine. Real type of transformation. So let's go ahead and put this one in and see what happens. And graph that, see what happens. Compared to the original, what changed? What did you say? Yeah, like it flipped upside down. So that would be a vertical reflection. So before we talk about these last three, let's just review really quickly the different types. So we have shifts that are vertical, that move up and down, or horizontal, that move left and right. We have stretches and compressions when we have numbers that are being multiplied, where it either gets narrower, skinnier, or it gets wider. And then we have reflections where it flips upside down. Sometimes all of these things will happen, sometimes just one or two, it depends. So the goal is to try to not rely on the graph and see if we can know what the transformations are without graphing it, but of course, if you still have to graph it, we can graph it. So let's look at this one. You can graph it if you need to. Try to compare this to some of our other ones. What would have changed if we graphed this, if we compared it to the original? It would, for this one, not right, but left, and then 1. So move is always opposite. You think it's going to move to the right because it's positive, but it does the opposite. What else would it, what else would it change? What else would change? There we go. I cannot speak today. It would flip. So then those two transformations would be what if we're looking at the actual rule? How would we write those? Horizontal, not reflection. So look back at
Horizontal
shift, left one. There we go. Kind of color code this so you can do things. And then what would the flipped be? What questions do we have so far? Yes, but sometimes you can't always see that. So like a horizontal reflection, if this is my y-axis, it does this. Yeah, it would do this. But sometimes you can't see that unless it also moves. Right. So looking at this one, this next one, you can graph it if you need to, but try to rely on your other examples. What changed? Okay, so that was stretch by 3, yes. Have our rules, vertical stretch by 3, vertical shift down 2. How would we write what changed, like what physically changed?
Got wider.
Got wider. Not wider, sorry.
Got
Narrower. And then the shift down 2. Now this last one has a bunch of things, so take your time, graph it if you need to. What changed in this last one?
Got wider.
You did get wider in this one. And you don't have to go in order, but you can, it doesn't matter. It did move right 3. And went up 1. We're just missing one more thing. It did flip also. So then let's write the rules for each of those. So for the got wider, what would that be? Not stretch. Not shift. Shift is always moving. Stretch is when it gets narrower. So compression. Vertical compression by how much? Or by a factor of how much? Not 3. Or the whole fraction.
1/3.
1/3.
Not the negative or
That's a whole different transformation. Right? Move right 3. What would that rule be?
vertical shift? 3.
Would that be vertical if it's
Horizontal.
horizontal shift? Right 3. Moved up 1.
Vertical shift 1.
Vertical shift up 1. And then the flipped. Vertical reflection. So it is good to know what it's physically doing, how it's changing, but you to describe it. But you should also relate those to the actual rules. The rules are what you need to remember and what you'll be tested on. Okay. Before we start the next page, what questions do we have so far? So now we're going to switch gears. Still do the same things, but our parent function has now changed. So we're going to regraph this, or graph our new parent function. So in your calculator, you're going to graph this. If you don't know where that is, the quickest way to get those bars is alpha window and the ABS. So alpha window, it should say ABS, and then you can put X in the middle. And then you can either graph it or look at the table. So this is similar to the graphs you saw on your quick check. I'm going to go to the table so we can graph our points. What's nice about this function is that it works the same as quadratics. Find repeating y values and find the middle. Do you have a question? Say that one more time. Oh, I just hit alpha window. So the middle of this would be 0, 0, just like your quadratic, so that's nice. And then we have negative 1, 1, 1, 1, negative 2, 2, 2, 2, negative 3, 3, and then 3, 3, and then it keeps doing that for every single set of numbers. So for these, we're going to plot as many points as possible when we get into graphing, but we're not there today. So this is the second parent function that you'll need to know, the absolute value function. If nothing has been changed, nothing has been done to it, it'll always look like this. Start at 0, 0, go up 1, right 1, up 1, left 1, on both sides. The changes are going to work the same. They'll just look different. So you can either graph this or compare your notes. What do we think is going to happen for this first one? Goes up by 2. So that rule would be what? Vertical shift up by 2. So that's the nice part about the transformations, is that there are no new words. It's the same. You just have to know how to apply them to everything. Alright, so then the next one would do what? down to, vertical shift down to. The next one.
Move left.
Move left to. Remember it's opposite. Left, up. So that would be, what would that rule be?
Horizontal.
Horizontal shift left to. And the next one. Moves right to. So what would that rule be? Horizontal shift right to. The next one. You can either graph it or compare your notes from the previous page. Did it fit in your ruler? So if you got narrower, what would that rule be?
Horizontal.
Not horizontal, vertical.
Vertical.
But stretch, yes. By how much? 2. The next one. Got wider. And what would that rule be?
Vertical compression.
Vertical compression by
2. 1.5.
1/2. The next one. Flip. And that rule.
Horizontal compression.
Not compression, not
Reflection.
horizontal reflection, but not horizontal. Vertical reflection. Now this next one I'm going to graph so you can see what happens, but you probably can guess what happened. There we go. Just go in some. So I'm going to do this. I'm going to graph the original and graph the negative so you can see what happens. And I'm going to make the original picture then the new one. I should have did that backwards. Well. Yes. Did you make a pass already? Mm-hmm. I'm gonna make this. There we go. So where is it? There you go. Yes, you can. So this is not really going to work on yours. You could do the same thing, but all of yours will just show up black. You could change the thickness, but you won't really see anything else. So there's the original. And you can see that the other one is graphed on top of it. So what Cameron was talking about earlier is that it did flip like this. It horizontally flipped, but you can't see it because it's literally right on top of each other. So the change would really be none. But this would be a horizontal reflection. Chris?
One side is a little bit pointing out towards the other way. Like they're not completely the same.
Did you see an example like that?
No, I was just going there.
Okay.
Will it happen or not?
Usually, if that's the case, it moved right or left. So that it wouldn't be the reflection at all. It would have to move. All right. So you can graph the next one if you need to. Find the changes for the 0.25 times the absolute value of x plus 5. What happened there? It would get wider in this case. So you can think about the 0.25 like 1/4 if that helps. Change it if need be. So it did get wider. And then what else? Up 5. So how would we write those two rules? Vertical compression by, so you can say 0.25 or by 1/4 either or. And then the other, vertical shift up, how many? For the next one, what two things happen? And again, you can graph it or compare your previous notes. It was split. And right side, yes. So what would those two rules be? Vertical reflection. Horizontal shift, how much? And yep, not left but right, and 7. And the next one. Was this one flipped? Are there any negatives in front of the x or in front of 5? No. So not flipped. Got narrower. It did move to the left too. And then our last one, down 1. So then what would those rules be? we say it moved to the left 2. Horizontal shift, left 2. And then the last one. Vertical shift down 1. Then we're briefly going to talk about this, the difference between the negatives and how you could really see it, but also may not at the same time. So just for practice, we know that, well, and it tells us, if this is our parent function, and we have -2 on the inside, it's moving to the right 2. If it moved to the right 2, and this happened, it's kind of like the second to last one we did, it would be flipped and moved to the right. I'm going to graph this one, I'm going to graph each set so you can see what happens. So this is our original, this is the one where it moves to the right, and this is the flip version. We'll talk about the last one here now. So that's our original. The red is it moved to the right. The black is it moved to the right and was flipped upside down. So I'm going to show what happens when we have the next one after we write our rules and changes. So we know it moved to the right. And it will split. And we know those transformations would be a horizontal shift right 2. And a vertical reflection. So in my calculator, I'm going to leave these first 2. I'm going to take this one out, and I'm going to put this one in so we can see what happened, what changed. We have our original, it moved to the right, and it flipped upside down. Doesn't that look like the one we just did? Oh, I did it wrong. Oh, I thought it went inside, but it came out well. There we go, now I should do it supposed to. So the blue was our original. The red, it moved to the right. The black, it moved to the right and reflected. So the only time you really see reflections is when it moves. You can see that it moved over, or it reflected over, but it's like the same as if it just moved over. So those get confused a lot. If you wrote it when you get to that part, or if you saw it as this instead, they would graph the exact same way, just to show that I'll do that really quickly. You graph on top of the black. So the negative on the inside, you sometimes can't see, and that's okay. As long as you know how to describe it, that's really all that you need to know about that. So we'll say what actually happened, and then we'll say what it also looked like happened. So what it looked like happen is that it moved to the left. But then what it actually did was move to the right. And horizontally. So I believe that in this case you wouldn't get something like that, but we'll talk more about that later when we get to later, because this would just be, and we haven't gotten to this part yet, and we're not doing this today. The practice on the next page, that would be like what the quiz and test questions are formatted like, and you would just have to write it. Write the equations. So then the look like rule was the horizontal shift. I wrote that one color. But the actual were that it moved to the right to and was horizontal. Horizontal. So then next class we're going to talk about how you can know what's vertical, what's horizontal just by looking at something and kind of what those look like and do some more examples. You do not have Khan Academy on this objective, but remember that you do on last class objectives, so you can be working on that. If you haven't finished your test, now would be a good time to do so. You could be, there's not really more practice on this except for the delta math. So if you want to try that, it's really just knowing parent functions and seeing what happened to them. You can try any of those things. If you want to work on retake stuff, you can also do that.